hope to get more people involved with that. But I'm going to introduce right now and let Arnhem take over. I just wanted to mention that this session, unlike our other benchmarking sessions, is being recorded. Please don't let that sacrifice opening up your camera, engaging with everyone, asking questions. This is meant to be a discussion with Arno from Upstream. So I let you take it over, Arno, and let you utilize your slides, and we get rolling. So thank you.
All right, just housekeeping. Let me know when you can see my screen before I start speaking and there's nothing on the screen.
We can see
your screen. See my screen?
We are good to go.
Do you see there the funny mascot, right? Okay, Melissa smiles, so it's working.
Yes.
I'm gonna keep my my face for the first few minutes, and then I'll let you focus on the slides because I think this is what matters. So thank you, Pam, both for inviting me. It's always a pleasure to be in Map Connected events and webinars. I think it's the second or the third one. I can't keep count. To anyone who don't know me, my name is Arnon. I'm one of those guys who call themselves as ex-Amazonians. I'm also a 3 times co-founder. So I was born in the dungeons of product and startup nation. So the melting pot. I currently run the automotive data intelligence here at Upstream. And hopefully, right, today, we'll talk about quality in the loop, if I'm not mistaken. So with that said, let me turn off my camera and focus all the attention on the screen. And let me see if the magic works. Change slides, yes. Okay. So the 2 facts about quality investigations today. Operations, they're complex, right? You have multiple tools and you've built, maybe siloed. The design and deploy might be separate in several groups. So eventually, the time it takes to get to root cause analysis, to get to the countermeasure, is weeks or months rather than days or maybe minutes, right? Maybe it's too good to be true. But the analysis requires deep expertise, and the path forward, you've heard that probably 5 to 20 times this week. It involves agents and human coexistence, and it involves us working together, not only with our colleagues, but with agents, and correlate and orchestrate and collaborate and all those pretty nice words. I'll argue that the vehicle is the ultimate physical AI system. Now, don't take my word for it. I've got a gentleman here, right, who stated that. And I personally, right, admire Jensen, but he framed it better off. NVIDIA framed it as a 5-layer cake. Now, it's famous, right? And I think that most of us have heard about the 5-layer cake, but I'll argue that the NVIDIA 5-layer cake is missing a 6-layer, because the way that NVIDIA frames the AI ecosystem and where they invest, right, is application sits on top of models and models sit on top of infrastructure, all the way down to chips and energy. But the 6th layer that connects all of them to the physical world, that's where the digital twin lives. And I say live digital twin as opposed to the simulation or design digital twins that are used back there at product, R&D, and design. And the live digital twin is the 6th layer that is missing to running real AI and ML models, let alone AI agentic models, on any complex physical system. And whether it's vehicles or robots, anything that operates in the real world and generate so much signal, you can plug your best, right? I love Claude, right? I work with the most advanced LLMs, frontier models. You plug your best model to a fleet that spits out petabytes of raw telemetry and try to run supervised and semi-supervised machine learning models. You try to run, large language models on complex dedicated tasks. It will fail. It will fail in production, not while experimenting. And you've heard others say, hey, why does 90% of experiments fail while bringing them to production? But I'm getting ahead of myself. Let's go to the problem definition, right? The defect that we're trying to identify was designed in, and the vehicle ships, and the symptom shows up at the customer 6 to 9 months later. And by the time warranty pattern is statistically viable, it might take months, maybe 12, sometimes 18 months. So you've built, you shipped, and you sold hundreds of thousands of affected vehicles. The lag is not a measurement problem, it is a measurement. And why does the board still track quality this way? Well, that is unfortunate, but it brings me to fact number one. Your fleet generates more data in 1 day than your warranty system sees in 1 year. And yet management still tracks quality by incident rate in 3 miss, right? Warranty cost keeps going up. So 3 miss, right? 3 months into service, or IPTV, incident per 1,000 vehicles. The industry standard for quality KPI, it's a lagging indicator, and it's dressed up as a leading one. So if that's the problem, what's the answer? Well, I believe it starts with how we think about the quality life cycle, and in particular, vehicle quality investigation. So any modern vehicle quality team, and we've spoken to hundreds of executives and field quality investigations and management teams, mid and high level, right? This is what a modern field quality investigation lifecycle look like, left to right, right? The pre-claim area, the green area, the holy grail, if you might say, before the first claim is even filed. This is where anomaly detection and trend analytics live, and virtual ride inspection, everything that happens even before the first mill is spotted on the driver's dashboard. So some would call it pre-DTC. The signals exist. Now, moving to the right, eventually people will start complaining and you'll start investigate vehicles. So whether it's 5 vehicles in or 10, or in some cases 20, you would have now prioritization agentic help that will help you either bucket better those claims, identify which patterns matter, triage, use digital signatures to say, hey, this is your potential lead to root cause analysis, and this is your control group. So this is how those vehicles are different than their healthy lookalikes. And most important, right, how many are still out there? So you're seeing maybe a tip of the iceberg under investigation, but there, God forbid, 20,000 more, or only 200, right? Whether it's a safety issue or convenience issue. So that's the under investigation, the bulk. And then on the far right, after you've identified the root cause analysis and defined the countermeasure, and right, countermeasure effectiveness matter, the targeted response is what happens post countermeasure. So how much did you get it right in the first time? And most of the people that we speak with, not you, other people, right, they say that they don't get it right at the first time. And this is trivial, but in an agentic area, right, you want to make sure that at least the agent that collaborates with you, right, would look into each and every countermeasure, develop its own, let's say, detection plan, and make sure that this clean point doesn't reoccur, or there's no symptoms reoccurring in the rest of the fleets, whether it's in the field or out of the factory. So the prevention closes the loop every time. So there are three, you might want to say, regions or time horizons, and one continuous process, right? But it gets even better. Let me explain why. We're at a very special moment in time as far as we see it, right? And I'm very passionate about that. You probably heard, or read one or two things. The first era, right, all the way to the left, I search, AI helps, right? We call it the early days, the 10% AI. It's claim-based, it's reactive, it's manual investigation, where the engineer drives 90% of everything. And this is where we started 3 years ago. First attempts, right? Chat with your data. The market has shifted, right? So now many are using copilots, right? I chat, AI answers. There's 20, maybe 30% AI with human initiated and AI response. This is where most of the industry is right now. But era 3 is the exciting era, right? This is where 60% is driven through AI. So AI speeds the investigation. I govern as the engineer. Let me repeat that. 60% AI. It's AI first, right? So there's proactive detection. You have specialized agents, whether they're homegrown or a third party, they're orchestrating. There's autonomous orchestration, but the engineer stays at the decision gates. So he or she can make the important decision while AI speeds up the work, the heavy lifting. Humans do the judgment. The most important thing, I think, is the transition from reactive warranty monitoring to a live digital twin, agentic quality intelligence. And I would like those words to sink in, because AI is way overused and agentic as much. But keep in mind that within AI, it used to be intelligence, right? And if we look at agentic quality intelligence, we're talking about a very specific kind of creatures. And let me show you how this look architecturally, right? You might be working with teams like we're doing right now or through Slack, and your engineers, right, might live inside your platform and looking into those live digital twins and interacting day in and day out. But some managers, right, only live in teams. Other managers would monitor and use other systems, like your maybe warranty management system, your social media sentiment analysis, your DMS, or any other system that you have carefully designed and developed over the past couple of years, or maybe decade. And all of those should and could now orchestrate and work together, whether through MCP or an agent-to-agent protocol. And even the older system that has an API can now be emulated to converse with the agents. So think of the live digital twin as the foundation. It's connected to all the systems that already exist. And there are 5 things that really matter. Security is first. No manufacturer would pull in an agent without making sure that it's completely secured, that it could be connected to any tool, but limited to the ones that you choose, that adding a new tool, whether it's your Jira or whether it's your GitLab, or if you're very advanced and you're using ready-made MCP, Agentforce, or ServiceNow to external or third-party MCPs. So there's cross-team visibility, and you can connect or bring your own agents. So it's open by design. Now, the conceptual frame, this is where quality in the loops comes in. And quick credentialing, who's behind this perspective? I already presented myself. Upstream is an AI mobility platform with two pillars, proactive quality detection, which is what this talk is all about, and cybersecurity, which has been our heritage for a decade. 19 OEMs, 40 million monitored vehicles. This is, not a theoretical exercise. The data foundation behind everything I'm going to show you is real. So now back to substance. There are three myths that I want to kill, or I need to kill, before the rest of the conversation makes any sense. And let's break them down one by one. So the first myth, we have visibility. Most cases, no. Where you have our dashboards, and dashboards show a state, and quality needs velocity of change. So most OEMs we speak with cannot answer, what about this particular phenomena, which is not only a DTC, but the correlation of two DTC, ambient temperature, and driver behavior. They could, but it might take them a few hours of analysis. So visibility, Digital twin is a BI tool or concept that's wrong, right? The live digital twin simulates, predicts, and drives decisions. It's infrastructure, it's not a view. And we'll come back to this. And the very infamous one, right? AI will replace quality engineers. Also wrong, because AI is the interface to the quality loop. To those of you who like ICE rather than EVs, like I am, it's almost the lubricant. It is not the oracle. The job of an AI agent is to compress time to hypothesis, to compress the time to root cause analysis and to countermeasure, and finally time to over the air from weeks, maybe to days. And the engineer will always govern that call. So today's talk is the paradigm that replaces all three. But before we go to the loop, every automotive quality talk opens with data is siloed. It is. That's not the interesting part. The interesting part is why the silos persist. Because R&D ships the vehicle and moves on. So quality feedback arrives after the next program has locked its design gates. Manufacturing owns the build, but not the life. Stuff that were designed, product doesn't change after delivery. And after sales inherits all those consequences, and warranty and recall are where the bill lands. And the only KPI that reaches the board. So although SDV or AIDV removes that last excuse, the vehicle you sold is not the vehicle in the field, because quality cannot and should not remain a downstream function. Which brings me to the second most important takeaway of today's webinar. We're talking about quality in the loop as a continuous system property, not a downstream function. And the infinity loop, right, has two halves. On the left-hand side, the engineering loop, it's design to build. What was intended versus what actually got shipped. This is the world R&D and manufacturing have always lived in. It's closed at the plant gate. On the right-hand side, right, the way the vehicle was built, then driven, consumed, then back to design. So what's shipped versus how it actually performs in the field, and that signal flows back into the next design. And this is the loop, the quality in the loop. So the vehicle sits in the center, and every signal it generates is the evidence for one loop or the other. And quality in the loop is what happens when both loops run continuously on the same evidence base. And when I say evidence, I refer to forensic evidence. Don't follow the failed part, or don't necessarily follow the broken one. Data tells a story. So the shift we're talking about is not incremental. It's almost a different operating model with different KPIs. A department, a budget line, a headcount, right? Quality is measured after the fact from claims and feedbacks that travel on human timescales and meetings and reports, and you know. They own the consequence and not the upstream cases or causes. And success metric is reduced warranty costs. Now, on the right-hand side, if you think about quality as a system property, the property of the vehicle is continuously measured, and quality is measured pre-claim from a telemetry drift. And the feedback travels on signal timescales. It could run in minutes, right? Or hours. It doesn't need to wait for weeks. So quality owns the upstream diagnosis, not the downstream bill. And the success metric is really to reduce your time to hypothesis. And just so you don't think this is a contrarian view, McKinsey just published the same point a couple of weeks back. So the AI Transformation Manifesto is a fantastic paper. There are 12 themes that separate companies winning at AI from the rest. And theme number 6 is the one that landed for me. Companies win that race when their operating model reduces the latency from insight to decision and decision to action. This is a very fundamental belief or tenet that we take very seriously. So the time to hypothesis is the latency metric, and what I just described is the operating model. McKinsey, our framing is the proof that this isn't an upstream argument or my argument. It's the operating model that defines competitive advantage in any AI rewired enterprise. And McKinsey asks every CEO, what are you doing to increase the metabolic rate of your organization? For automotive, quality is that metabolic rate, and it gets tested first. Okay, I think we laid out the foundation. Now let's talk about layers. The data layer, right? The unified data. Without it, the loop cannot exist. So yes, you've got telemetry, you've got customer service, you've got production and the SBOM and the RO. You don't have a data problem. The data exists, the signals stream, the claims are recorded, everything is running well. What is missing is the stitch. Okay? It's your silent partner, right? Bill of material and software bill of material, the customer service, weather, geography, social media, stitching them all together is really hard. So joining data across the life cycle from various systems and then various platforms for a single pane of glass is that engineering investment that defines whether you can run a quality loop, right? And the OEM winning the next decade are investing in stitching today. So that was layer number one, which seems obvious. Now, the layer two talks about context, turning data into something usable, connecting signals to components and configurations and behavior. This is the live digital twin. So what the live digital twin actually is versus what most people mean when they say digital twin is in the next slide, because it's been used for many, many years by now, and it's been diluted. So let me give you my take on it. On the left-hand side, you have a visualization of a current state, right? The representational twin shows what the vehicle looks like right now. It's a read-only. It doesn't get updated. You know about that digital twin. On the other hand, on the right hand, the live digital twin, it's a model of the vehicle's behavior over time. It remembers the history, the rides, the software baselines. It even allows you to build time machines. So trace back to where it started and what happened next. And the live digital twin is the data foundation, not a view on top of it. Because you can query it, you can hypothesize with it, and you can ask non-trivial question, was this ever normal? Right? What is different? And since when? Now, the live digital twin works at 4 levels of granularity, top to bottom. The fleet, right, where the trends and the cohort behavior baseline drifts, where you spot a problem. Then the vehicle, right, the per VIN history, the software baseline, the repair history, where you confirm it, the component, the ECU level state, the supplier badge, the revision, where you isolate it, and then the signal, the per event telemetry, the raw ground truth, where you prove it. So the investigation starts at the top and drill down, never the other way. The raw signals are expensive and noisy and almost useless without context from the layer above. So anyone who tells you, we'll just run ML and LLM on signals directly, they never tried it. Fast forward, layer 3, right? AI is the analytical layer. It's not a tool in the architecture. It is the interface to the quality loop. And the framing most of the industry got wrong is this one, right? If you go back to 2025, every vendor slide deck calls their AI an assistant or an answer engine. The framing is wrong, and there are 2 ways AI shows up. One is probably wrong, and one is right. On the left-hand side, AI as the oracle, right? Ask a question, get a verdict. It's a black box. Engineers don't like black box. I don't like black box. I want reasoning, right? I want probability, and I want to be able to reverse any decision. So rather than replacing the engineer who slow things down, I want to evaluate by the answer quality, not the decision quality. So that left hand, AI as the oracle, is definitely wrong in my view. AI as the interface to compress the time to hypothesis from months to weeks to maybe days, where it surfaces the evidence and the rationale, so the engineer weighs in. This is how collaboration happens. So it multiplies engineers who were already good. And it's evaluated by the decision quality and the latency. not how quickly it spits out an answer. And that's the operating principles that separate a thoughtful agentic system from a plausible one, so that AI proposes and humans dispose. Now, the four things that AI does in this architecture, right, aside from orchestration: pattern detection, right? It can scan fleet-wide telemetry for statistical deviations before any human notices them. It can detect that 0.3% drift that matters inside that 99.7% that doesn't. The digital signature. It identifies the feature level fingerprint and footprint that separates affected vehicles from healthy lookalikes. Prioritization. So, is this a safety issue? Is this a huge scale? What's the severity? What are the predicted costs? It stops the 500 open tickets trap. And last, yes, you want to converse, right? You don't want to code. You don't want to do any SQL query. I definitely don't, right? You want natural language access so that you or R&D or your tier one or your legal or your safety guys can query the same forensic evidence in plain words. So no more gatekeepers, no more fancy, right, BI and days of SQL data engineering. So the evidence becomes shared, not siloed. Now, in an ideal world, and I know that this might look far-fetched, but hey, by the pace of innovation and the AI and agentic announcement that comes every day, if you think about this this world where you have, almost an agentic orchestration of detection, investigation, contain, resolve, and prevention, right? The core are the live digital twins. And then there's AI and machine learning layers, right? But if you want to contain and you want to communicate with manufacturing and supply chain, you want to have an agent, right? In your warranty management system, you want to connect to your dealer management system. If you want to investigate, you want to have that prioritization agent that we mentioned, and you want to have a root cause analysis agent that would help you prioritize or investigate. You also want to have that detection architect that would look at every single new countermeasure or TSB and automatically translate it into a detection plan without you overthinking it. And obviously, all the other potential agentic use cases throughout the loop that we talked about. Now, the three places where this has already played out, not hypothetical, we see OEMs around the world using this to show millions of dollars of savings every week. But most importantly, forget about the value creation and the financial impact. It helps them speed up that process. I might, go through a few examples. Let's talk maybe about, ADAS degradation, the drift. So the radar and camera infusion drifts slowly with environmental exposure, no single DTC. There's warranty silence, but telemetry drifts are visible from week 3. And the outcome was pre-claim containment via over-the-air parameter adjustment. No recall, no safety incident in this case. The other case, that 3-letter abbreviation all too well, the no trouble found, right? In one case, there's a 30% plus of warranty claims closes at NTF that technicians cannot reproduce, and the outcome, basically fleet telemetry confirms the fault existed at a specific operating condition that was not reachable in the bay. In that case, the NTF rate was cut by half in some of those methods. In the last case, right, the silent regression, the new software baseline degrades 12-volt battery longevity, and the vehicle keeps waking up more often when parked. So the symptom might be in the battery degradation, but the root cause lies in the TCU upgrade, and the outcome, it's isolated a single sleep mode change, and the fix was shipped via over the air. Now, what changes for each function, right? R&D before, quality feedback arrives after the next program is closed. After, field signal feeds the current program, and design decisions are informed by live data, not extrapolations. In manufacturing, before, the PPAP and APQP built for a product that does not change after delivery, and in SDV or AIDV, it breaks the assumption, right? After, the build state is continuously verified against field state, and the gap is the signal. And last but not least, in Aftersales, if before you inherit the consequences and the board tracks the bill, the warranty cost is the proxy, the after state is you own the upstream diagnosis, not the downstream bill, and the time to hypothesis replaces warranty. The loop only closes when all three functions really work and operate on the same evidence base at the same tempo. So before we wrap up, right, if I want to kind of recap and give you 3 takeaways or things to think about. We talked about data unified and stitched. We talk about context, the live digital twin. We talked about AI as an interface to the loop. And we talked about the operations, the orchestration. And warranty is a lagging KPI. So if you can replace it with time to hypothesis, time to root cause analysis, time to countermeasure, that's a win. Second takeaway, digital twin is infrastructure, not a dashboard. So you might want to invest accordingly. And third, AI is the interface to the loop, and engineers stay at the decision gate. I will probably hand it back over to you, Pam. And let me see if you can still see my screen and pause screen sharing. Okay. Do we have, I know we're running short on time, but Pam, do we have any questions from the audience?
Yes. Do we want to feel free to turn on your mics and cameras? Jim Tankard, did you want to continue to ask your question to Arnon?
I think it was answered. It was earlier in the presentation. I asked, is live digital twin an agentic platform from Upstream? That is, it's essentially you clarified that as being an infrastructure, right, where you have the data and the agentic kind of layer that's incorporated within that, so that field service technicians can ask questions about the quality data, right? Did I get that right?
Yes. So if you think about the foundation layer, which is the physical AI as the car,
yep.
After you normalize and cleanse all the data, you have to have that translation layer, which we call live digital twin, which is a digital representation of every single vehicle, but its rides rather than its telemetry.
Right. It's
So
not using historical information, it's using real-time information in that digital twin.
So it both gives you the current situation, but it also stores all the historical information,
Okay.
but pre-processed. So let me say it's AI ready. So it's almost a translation layer back to Jensen, right? You cannot put an LLM on that raw data and expect a miracle or magic or fairy dust, right?
Mm-hmm.
There needs to be that translation layer that makes ML, whether it's supervised, semi-supervised, AI, or agentic, to work and make sense out of it.
I got it. So it's all the machine learning algorithms that are baked in. It's all pre-processed information so that you've already done the kind of the translation or the ETL process basically on that data and hooked it up to a number of different machine learning algorithms that make your agents super intelligent. Did I get that right?
I would say that even before machine learning kicks in, there's a fundamental layer which is the data foundation, right? Translated to be AI ready and ML ready. So before dropping in your machine learning, you want to make sure that every single vehicle that drives in the field and sends out, I don't know, 10, 20, 50 gigabytes, right? Depending on how advanced you're on the SDV or IADV, that raw data package into a digital twin that captures not only where was this vehicle at this point in time, was it hot or not, what was the driver pedal position at that particular time 2 seconds before the DTC fired, and what was the ECU software version of that lane keep assist camera at that point in time. So you keep all that information rather than raw data, but ride by ride, aggregated, ML ready and AI ready.
Got it. So you did all the
Yep.
feature engineering on there, the correlation to all of the different stuff, right? So that it's ready for the machine learning and for the AI algorithms, massaged into a
Precisely.
JSON string, for example, and then put it very clever. Nice. Thank you.
Thank you. Thank you. Great question.
Any other questions? Jay Dupree from Kia.
Quick
Go ahead,
question.
Jay.
So, I think this is great, and I think for any of the other OEMs here, you're preaching to the choir. We know that this is where we need to be headed. But I wanted to know if you could touch base on any other aspects of the business besides quality. For example, service. You know, how can we leverage the data to improve the customer experience when they pull into the service drive, whether that be through, you know, parts inventory or the dealership being more prepared for the customer. There's a couple of small examples, but I was just wondering kind of your ideas or your vision and other areas for this type of tech.
Yeah. So you're spot on. I think when we started 3 years ago, right, we were tackling the after sales because they are carrying the bill. But today, and we see that with OEMs in the US, in Europe, and in Japan, they, by design, expand that to other areas of their business. Service is one. R&D is obvious, right? I want to say, hey, Houston, or in this case, Detroit, we have a problem. But I don't have enough evidence because I don't have enough claims. All of a sudden, you bring in a full dossier or document with forensic evidence that maybe, right, could move R&D in a faster pace. So working backwards or shifting left to R&D was the first move. The second one was parts. Can I predict better what would be the fail part that would be needed in that region based on quality issues that I see in the field? And can I get ahead of the curve? Number three, you're right on the mark. And the question came from?
Dave Dupree
Sorry.
from Kia.
Yeah, sorry.
Okay. No worries. So you're spot on. Being able to equip technicians at the bay with a better potential root cause analysis, right? Rather than the 50 or 90 page unusable PDF is a huge next step, right? So we see a demand, a clear demand to make those technicians work faster and more efficient. So even if they have the right parts, right? What is the lead to the root cause analysis? Where do they need to go to first, rather than follow, a very well-known path, right? So, a case which you might know all too well, one OEM with over 12,000 replacement of a 12-volt battery because the 12-volt battery depleted while the problem was with the alternator. If you look at the telemetry, you see that the 12-volt battery currency during a trip was coming down. So this is an obvious case, but you can imagine, right? If you have the right data, if you have the forensic, if you have the right, and now with, Agentic being able to orchestrate between those systems, you don't need to install anything at the dealership. And they don't want to install anything, let's be honest, right? But they can use Teams or Slack, right? And they can connect to your system and ask the main agent or the chief agent, right, about a particular case. And that could speed things even faster. I'm sorry it was a long answer to a short question.
No, that's good. Kind of what I was thinking. I just wanted to expand on it, and I'm sure, like you said, that's kind of where you guys started. And obviously, quality is the highest impact area, because if we can prevent the quality issue or close it, we don't have to deal with the cars even coming to the service bay. So, thank you. Appreciate it. Appreciate your time. My other question was, will this recording, Pam, be shareable to some other people in my organization?
Absolutely. So,
Okay.
so tomorrow I'm going to be releasing the recording from last week's session. That was the Stellantis and ServiceNow case study. And then I would assume next week, one day we'll pinpoint that this one will be available to be released. And then just wanted to mention we have two other in this series. The next one scheduled for May 12th, which is a Toyota and Pegasystems case study, and then June 9th, a extended warranty and case study with circuitry.ai. So, but just tomorrow and sometime next week, you'll get access to this one. So.
Okay. Thank you.
Mm-hmm. And Arnon, you plan on